A line includes at least 2 points. 2 points are, by necessity, collinear and coplanar. A plane includes at least 3 non-collinear points. A line and a point are, by necessity, on the same plane. 2 non-parallel lines on the same plane will always intersect and form a point. 2 non-parallel planes will always intersect and form a line. That all measurements are positive numbers is based on the idea that a negative number cannot be measured. Negative numbers is an invention to represent the other side of any numerical application. For example, a gain is represented as a plus, while a loss is represented by a negative. But in reality, all these values that can be measured are absolute in nature and positive. That all values have transitive properties means that values that are equal are transferable. So that if angle A equals angle B and angle B equals angle C, then of course angle A must also equal angle C. If a segment is bisected, then it has one midpoint only. Establishes the fact that bisecting means cutting in half. So if an integral quantity has to be turned into 2 equal parts, the 2 equal parts must be separated by one common element only. That is the point that divides them. That congruent segments, angles, and figures have reflexive, symmetric, and transitive properties explains the importance of comparison in geometry. Geometry is a way of communicating what we see by comparing basic shapes. Therefore, the properties of equality by reflection, or mirror image, symmetry, or that another equal half may be shown, and transfer, in other words, applying it to different situations, define the limits of what we can and cannot do with geometry. For example, a rectangle could represent a window or a box. However, in both applications, if the rectangle's property of equal diagonal is not met, the objects, in this case the window and the box, are worthless. The window will not open and the box will not close.